Okay, so now it's asking us to express 5x squared minus 8x minus 5 over the quantity x minus 1 times x squared minus 1 in terms of partial fractions. So when we're dealing with partial fractions, the really important part to take a peek at first is your denominator, because that is going to kind of drive the whole problem. So we have x minus 1, and we also have x squared minus 1. Well, for this, what we're going to do is we're going to want to separate this into two different parts, okay? So this part here, okay, is we're going to have our x minus 1. Now, x squared minus 1, that is the same thing as x plus 1 times x minus 1. So what we have here is, if we factored out the whole thing, we would have this. This is the same thing as our denominator. So in a sense, what we actually have is x minus 1 squared times x plus 1. Okay, now this is important because what we're going to have is, this is going to split into three separate fractions because we have kind of three separate binomials. You have, a cube. So we can have three separate fractions here. Now the way that this is going to separate is it's going to be like this. We're going to have one of our fractions, it's going to have our x plus 1. One of our fractions is going to have an x minus 1. And then the last fraction is going to have our x minus 1 squared. Okay, so that is how this is going to look here in the grand scheme of things. This is when we have more than just like the product of two binomials. When we have the product of three binomials, we will have three fractions, and we have to break it apart in this way, where we'll have the single term, the square term, and then that same term squared will be the end. Now, to construct our big equation where we can solve for a, b, and c, what we're going to need to do is, in the other method, we kind of did the cross multiplication type thing, where we multiply down and around and whatnot. Well, we can't do that here because we have 3. It becomes more complex. So what we're really looking for is, what does each fraction lack in terms of the greater overall part? Well, for this right here, the fraction with a in it, if we look at the big overall part here, it lacks the x minus 1 squared, so we are going to tack that onto it right here. Our b has an x minus 1, but it does not have the other two things. It doesn't have an x plus 1, and it doesn't have the other x minus 1. So this becomes an x plus 1 times x minus 1. And our c has the x minus 1 squared, but it lacks the x plus 1, so c gets the x plus 1. Now this whole thing is going to equal our numerator, which we had here earlier, which is 5x squared minus 8x minus 5. So we're going to write all this out real small, like. So we get x times x minus 1 squared plus b times x plus 1 times x minus 1 plus c times x plus 1. That equals our 5x squared minus 8x minus 5. Make sure that's right. Okay, so that's all right. So now we have to figure out, how do we go and find out what our numbers are? So what we need to do here is we are going to plug in some different numbers in order to find what these are going to get us. Okay, so let's say we decide to plug in the number 1. So we plug in 1. Now that would be a number that could eliminate at least one or multiple variables for us. Well, if we plugged in 1, we would get a times 1 minus 1 squared plus b times 1 plus 1 times 1 minus 1 plus c times 1 plus 1 equals 5 times 1 squared, which is 5, minus 8 minus 5. So this zeros, this will zero, and we'll be left with 2c equals negative 8. So we get c to be negative 4 here. So we have that number automatically. Well, that's excellent. So we picked a 0 to help us find what one of our other numbers could be. Now, let's say we tried a different number. So let's say we tried a negative 1 here. So if we plugged in negative 1, what would happen? Well, if we plugged in negative 1, we would get a times negative 1 minus 1 squared plus b times negative 1 plus 1 times negative 1 minus 1 plus c times negative 1 plus 1. That would equal 5 times negative 1 squared is 5. We get plus 8 and minus 5. So we go and kind of solve this out. This would be negative 2 squared. Negative 2 squared is 4, so we get 4a. We then have over here, this would make 0, so this zeroes out. Over here, c, that zeroes out. And we are left with the 4a is going to equal 8. So here we have a equal to 2. So now we need to figure out how do we get any of these other numbers for us. Okay, well, we use these two numbers here along with some other number that we're plugging in order to get everything together. So now we're going to plug in 0. Well, we know automatically off the bat that a is 2. So we are going to have 2. And that is going to multiply by, right, the number that we're plugging in, which is 0 minus 1 squared. And then we're adding b times 0 plus 1 times 0 minus 1. And then we add c, which is negative 4, times our 0 plus 1. And that is going to equal, when we plug in 0, so 5 times 0 squared is 0, minus 8 times 0, which is 0. And this will end up equaling negative 5. So we just got to go through and evaluate our math. Well, negative 1 squared is 1, so we're going to have 2 times 1 is 2. Over here we get 1 times negative 1, so we get a negative b. And then we have negative 4 times positive 1 is minus 4. And that all equals negative 5. So here we have negative 2 minus b equals negative 5. And so we would have that b is going to have to equal 3 here. So our three fractions that we have, we've been able to find 3 separate values that are going to add all this together. Now that we have these parameters, we're going to go ahead and plug that all back in to make our final answer. So we had a, which is 2, divided by, which was our original thing, which was x plus 1. And then our b, which was 3, that was divided by x minus 1. And then we had our c, which we found at the beginning, which was negative 4. So we get minus 4 times x minus 1 squared. And that is the deconstruction of that particular fraction. Now, if you have, 3 separate binomial factors, you've got to have it set up like this to where you have one of the factors, the other factor, and then the other factor that is doubled or squared. And then you'll have 3 different ones to have to find a, b, and c. And so you have to use those test points along with your logic throughout the problem in order to figure out how to get to this final answer.